ESA and NASA are now kind of really banging heads together about the whole Mars sample return mission, because obviously with a delay in Rosalind Franklin, that was due to be launched this year. It's kind of set things back in terms of what the whole plan was. Now, Ros Franklin wasn't supposed to be part of the whole Mars sample return thing. It was more of a kind of demonstration and advanced rover concept. It would have been the first time that the European Space Agency had ever landed anything successfully on the surface of Mars. You know, they've had a few attempts with Beagle 2 some time ago now, which was a kind of British developed small lander mission that got down to the surface, but the petals didn't unfurl. We all know about what happened with that on Christmas Day. It was horrible. And then obviously with the Schiaparelli lander, which was part of this initial kind of re-exploration of Mars. So now ESA are incredibly successful when it comes to Mars orbiters and Mars Express, Trace Gas Orbiter, etc., all doing fantastic work and continuing to do fantastic work. But the idea to get something down onto the surface was heavily reliant on Roscosmos. And we talked about that in the last show with the Kazachok lander, and all of that's no longer happening. So the mission now is, instead of it being a kind of single lander and then MAV, like in the Martian, the MAV, the Mars Ascent Vehicle, so kind of single lander with what they call a fetch rover, so a small rover which is designed to pick up the cached samples that are being drilled by the Perseverance rover, put into these sample tubes, and then kind of dropped on the Martian surface for later collection. Now, the original idea was to kind of have a singular vehicle that was going to go down to the surface, have an ascent stage, ascent rocket, and this small fetch rover that was effectively going to land not too far from where Perseverance is, obviously for logistical reasons. Pick up the samples, bring them back, use a robotic arm sample transfer mechanism to get them into this launch vehicle and up to an orbiter, which is a kind of European Space Agency orbiter with some NASA components on board as well in terms of the caching sample, return sample transfer mechanism. Get that back to the Earth, and then you'd have a descent vehicle coming back down. That was all going to be kind of in a free stage. Now it's been split out. It's going to be, in many people's opinion, a better solution, a more logical solution, in that they've split the singular descent vehicle, which was incredibly high risk if you think about it. You look at the success rate of anything getting down to the surface of Mars, and it's quite low anyway. In terms of Russia, it's 0% pretty much. I mean, Mars 3 for 12 seconds, transmitting a few lines, that's about it in terms of any European or Russian success. China have a higher what's called TRL level than the European Space Agency or Russia. China have got something successfully onto the surface of Mars. So this delay has kind of set it back a bit. And Perseverance is there. It was phase one. So Perseverance there to cache and collect these samples. Phase two, as I said, was going to be this multi-pronged approach with quite a large heat shield mechanism and a system that had never really been tested or deployed before. So again, really high risk. What they've now decided to do is split the Fetch rover and the MAV ascent vehicle into two separate vehicles, as it were, both which will descend using methods that are already tried and tested with both Curiosity and Perseverance, being the Sky Crane, Adam Stelter and his team's incredible Sky Crane, which everybody said was complete madness anyway, but they've done it. So this is now going to be called SRL-1, SRL-2. So Sample Return Lander / Fetch Rover will be SRL-2. So that will go down and small rover, pick up the cache sample materials, then that'll take that back to the other lander vehicle, the MAV, which will then transfer the Mars samples. It gets quite complex. Transfer the Mars samples into that. That will then take off from the Martian surface, but it won't take off in a traditional method. They're going to have to slingshot it up first, then fire the engines, then ascend to a 500-kilometer orbit around Mars, then rendezvous with the orbiter. The orbiter is then going to have to dock with it, transfer the samples from the Mars Ascent Vehicle's sample caching system into the orbiting vehicle. That orbiter is then going to have to do a burn, a kind of trans-Earth injection burn to come back to Earth. And then the scariest bit is, well, not quite the scariest bit, the whole thing's pretty scary. But once it gets into Earth orbit, you'd think, oh, parachute descent, it's going to be. No, they're just going to crash land into the Utah desert, which is quite terrifying given, what's happened in the past. But they're building a shock mounting system. It should be able to take the impact. But it's going to be as you can probably imagine, with a Mars to Earth sample transfer injection burn, you think about from the Apollo days, some of the highest velocity re-entry vector or re-entry velocities by the Apollo astronauts exceeding 20,000 plus miles an hour. This is going to be a really high risk, high speed. I mean, obviously they're going to decelerate and go into Earth orbit as well, but it's still going to be high risk.